Welcome back. So this is your MotionView graphical user interface, and we will continue with the demo on exercise 1. In this exercise, you will learn to open and save HyperWorks desktop session, switch between different HyperWorks clients, manipulate the appearance and orientation of animations and plots, create and modify HyperWorks desktop windows, open and save a model in MotionView, navigate through the project browser, and also select and modify a MotionView entity. So let's go to the File option in the main menu, and then go to the Open option, and then click on Session. So all the model files, they're organized the chapter wise in this particular folder. So you can go to chapter 1, okay, and then click on this particular session file that's already been created, Indie Full New, and then click on Open. So when you open the file, you can see the session file that's created. So it is the MotionView model that's already been built, and these windows that you can see is basically Altair's post-processing software. HyperGraph is used to plot, and HyperView is used for animations. Here we have this particular toolbar, which is a client-specific toolbar. This is the play button, and these are the animation controls. So you can play and pause using this button. So this is for fast forwarding it, going back, and this bar can be used to adjust the frame rate to increase the speed of the simulation or decrease the speed of the simulation. And as you're seeing, all the windows are synchronized, so you can take a look at the animation. So this is in HyperGraph and this is in HyperView. So the full page here is divided into 6 windows. Okay. So we basically choosing this option, and we'll be basically dividing one single page into 6 windows, which will have different post-processing results. So let's experiment with a few things here. So as I mentioned, this is for the animation control, and now we can go to, you can see this blue color highlighting line when I click on this window. Okay, so this particular thing calculates the CG acceleration with respect to the center of gravity for this particular model. So what we can do is we can go to this option here, or we can click on this particular window and then click on this option. This is for expanding or reducing the window. If you click on this option, we can expand that particular window in one page, and if you click the same option, it goes back to its previous state. And then this option is basically to swap the windows. If you click on this option, and if we move the first window to the last window, this gets swapped here, and we can swap it back. So this is used for swapping the windows, and this one is for synchronizing the results that's being played in the different windows. So now they're already synchronized. All these windows are already synchronized here, and you can click on this. So here I'm holding the control key on my keyboard, and I'm using the left mouse button to rotate it. Okay, and for panning we have to use the right mouse button along with the control key pressed on the keyboard, and this is for zooming in and zooming out, wherein we basically hold the control key on the keyboard and use our scroll button on our mouse for zooming in and zooming out. So these are some basic controls that you have to know when you're navigating through your model. So now let's switch between the different HyperWorks applications. So this is the icon that you see for HyperView. As I mentioned, this is for looking at the animations. So we have this drop down arrow here. We can click on that, and we can switch between the various applications. So we can go back to MotionView. So in this window, we had HyperView, and now it's switched back to MotionView. Okay. So all this is possible. So now let me just go ahead and create a new session. File, new session. So this erases the previous session that's there on the screen right now. Say yes. So this is your fresh new session. And now here, let's open a model. Go to File, Open, and last time we had selected Session, so it opened a .mvw file, but now we'll be opening a model. So let's go to Chapter 1, and in Chapter 1, we'll be selecting the single cylinder engine model. A very simple basic model, so which has already been built. So let's review this model. So this model, it has 6 bodies. The ground body is always created by default whenever you open a MotionView window or when you start the software. The ground body is always created by default. Along with that, we have the crankshaft. So what happens is first you need to create the body, and then you have to create the graphic and associate the graphic with the body. So this is the crankshaft. And then we have the connecting rod here. We have the piston, which is inside, this gray stuff that you can see on the screen. And the pin is the blue part. And we have the outer cylinder. Okay. So these are different bodies which are used to create this model. And the graphics that are used, we're using all these are the primitive graphics which are available in MotionView. So we're using a cylinder for crankshaft, cylinder again here for the crankshaft. This part, this highlighted part that you can see is also part of the crankshaft, which is modeled using the cylinder. Same thing even here. So the whole crankshaft is modeled using 4 cylinders. Cylinder 1, 2, 3, 4. And then we have the connecting rod here. Again, which is modeled using a cylinder. We have the second part of the connecting rod, which is again modeled using cylinder. The piston, the gray part which is inside, modeled using the cylinder. This is the engine cylinder. And the pin again, which is modeled using the cylinder. So all these parts that you're seeing on the screen are modeled using just one graphic, one type of graphic, that is cylinders. Okay, and we have 6 joints in this model. So if you click on this, you can get to know that we have a joint here. You're not able to see it because the whole model is opaque. So let's go to the graphics option here, and then we can select all. So this selects the full model and you can make it transparent. So now you can see the various joints here. Okay. So this is your first joint, which is the cylinder pin joint to the connecting rod. So it's basically a ball joint that we have here. And then we have a fixed joint between the pin to the piston. We have a fixed joint. And then we have a revolute joint here between the crankshaft and the connecting rod. We have another revolute joint here between the crankshaft and the ground body. And we have the cylinder, and we have a cylindrical joint between the piston and the cylinder. Okay. This particular joint that you can see. And we also have a fixed joint between the cylinder and the ground. So this is how the model looks like. And this global frame marker is created by default when you open a new MotionView window. And there is one motion that's applied on the crankshaft for the crankshaft rotation. So you can either define a motion on a joint or it can be using markers. But here it's defined about this particular revolute joint. Okay. and they're requesting two outputs to measure the displacement, to measure the piston motion. So the displacement output, and for the crankshaft rotation we have the velocity output. So we are requesting these two outputs. Okay. So now we've finished exploring the model. So now let's open the motion folder and click on this crankshaft rotation. It highlights this motion, and if we go to the connectivity tab, it will show that it is 1. So, and by default it is in radians per second. So 1 radians per second motion has been applied on this particular revolute joint. So it is going to rotate this crankshaft at 1 radians per second. So let's see that. Go to run option and then click on run. You can leave the simulation settings as it is by default, and then you can run. So the model is run. You can click on close and click on the animate window and click on the animate button, so that it divides the page into two windows, and the right side is now the HyperView window and the left side is the MotionView window. So now you can click on play and you can see that the crankshaft, it rotates at 1 radians per second. Here you can just see it rotating, but you can't see the actual value. So to see that, we need to plot the graph. So for that, we need to go ahead and use the Altair post-processing software HyperGraph for plotting the results. So let's go back to MotionView and click on plot. So if you click on animate, it automatically brings up HyperView, which is Altair's post-processing software for animation. And if you click on plot, it is going to bring up HyperView, which is used for plotting. Okay. So it divides the screen now into 3 windows, and it brings up the HyperView window here. So you can go to marker velocity and then click on the crankshaft rotation, and then it is in the X direction. So the Vx, Vy, Vz is basically the XYZ component in the linear, it's the velocity in the X direction, Y direction or the Z direction. But now it's rotation, so we need to check, we need to select either WX, WY or WZ. And we can see from the screen that here it is oriented along the global reference frame, and this will be the rotation about the X axis. So let us select WX and say apply. And you can see that it is at 1 radians per second. And both these are synced with each other. So it is moving at, or it is rotating at 1 radians per second. Right? Okay. Now what we'll do is, we'll come back to this, our MotionView model, and make it and enlarge it. Once we enlarge it, we will do slight modification. We'll go to the motion here and we'll change the value from 1 radians per second to 10 radians per second. Okay, and now we'll run the model. So go to the run option here and then now save it with a different name. Okay, we'll save it as single cylinder engine model underscore 10 radians per second, and click on save and then click on run. Okay, now let's go to the animate option to bring up HyperView, and you can see that the crankshaft is rotating faster and at 10 radians per second. So to go to the plotting, we can just go back. Okay, we can go back here and go to plot. So this is the fresh plot window. So let's go to the marker displacement and go to piston motion here, and then select let's go to marker velocity option here and go to crankshaft rotation and select the WX for the rotation along X-axis and click on apply. You can see that now it is at 10 radians per second. So you can see these peaks like this only because that's the disturbance in the model. Don't worry about this, but you can see that the value in the y-axis is all 10 and it is at constant 10 radians per second. So this brings us to the end of the exercise demo on chapter 1. Thank you.